In this video, let's practice solving some one-step equations together. For problem 1, we have the equation x plus 14 is equal to 32. To solve this equation that has addition in it, we're going to go ahead and use the subtraction property of equality, or subtract 14 from both sides of the equation to solve it. By subtracting 14 from both sides, the 14 minus 14 is going to be equal to 0, so we're going to have x plus 0 is equal to whatever 32 minus 14 is. And 32 minus 14, I believe, is equal to 18. We don't have to write the plus 0 because of the identity property of addition, so we can just drop that and write x is equal to 18. While we have a solution here of x equals 18, it's important that we actually go ahead and check it to make sure it works. So substituting in 18 for x, we'll have 18 plus 14, and let's see if that's actually equal to 32. So let's see what 18 plus 14 is. Well, 18 plus 14, go ahead and add just like this. 8 plus 4 is going to be 12, and then carry the 1. 1 plus 1 plus 1 is 3, so that's 32. So we actually can here say that 32 does equal 32. And if we know that is an accurate statement, then this is true. Let's try another one. For problem 2, we have the equation 37 is equal to y minus 43. To solve for y, we're going to use the addition property of equality and add 43 to both sides of the equation. Okay, so if we go ahead and add 43 to both sides, on the left side, 37 plus 43 I think is going to equal 80, and that's going to be equal to y plus 0. Remember, those opposites become 0. Then we can go ahead and use the identity property of addition and drop that 0 and just say that y is equal to 80. Now, to make sure that 80 is the correct value for y, let's go ahead and substitute it into the equation to see if it actually works. So let's see if 37 is equal to this 80 minus 43. And so if you have a calculator, obviously you can check it just like that and subtract. But if we don't have a calculator, it's also good practice to go ahead and do this by hand. So that's going to be 7. We got to borrow here. That's going to be 10. 10 minus 3 is going to be 7. And then 7 minus 4 is equal to 3. So we're going to get 37. So the left side of the equation is 37. The right side is also 37, so that works out. Let's try number 3 here. For number 3, we have the equation 48 is equal to k plus 19. So to isolate this k, what we're going to have to do is take away 19 from the right side and take away 19 from the left side as well. That's the subtraction property of equality. Okay? On the left side, 48 minus 19, let's think about what that's going to be. I think that's going to be 29, so we're going to go ahead and write 29 over here, and it's going to be equal to k plus 0. That plus 19 and minus 19 were opposite, so we have 0. Then we can go ahead and drop that 0 by the identity property of addition and just write that k is equal to 29. Let's check to see if this works. So let's go ahead and write 48 is equal to, and let's plug in this 29. Hopefully 29 plus 19 does equal 48. And what is 29 plus 19? Well, 29 plus 19, very straightforward to check here. 9 plus 9 is going to be 18. Carry the 1. 1 plus 2 is 3. 3 plus 1 is 4, so that's 48. So if we can go ahead and say 48 does equal 48, then we know this equation must be balanced and true. Here's question 4. For this equation, we have p minus 24 is equal to 87. So we're going to go ahead and add 24 to the left side and add 24 to the right side. That's just using the addition property of equality. And if we go ahead and do that, that minus 24 and plus 24 becomes 0 because they're opposites. And on the right side, 87 plus 24 is going to be 111. We can go ahead and drop that 0 from the identity property of addition and just say that p is equal to 111. Now, I hope that's right. We can go ahead and check that. So we can go ahead and take that 111 and substitute that in for p, that's what we think it is, and see if we take away 24, if that's actually equal to 87. So let's go ahead and check that now. We have 111 minus this 24. Let's see how this goes. We need to borrow, so that's going to become a 0. That's going to become an 11, but we're going to borrow again, so it's 10 really, and this is going to be 11. Okay, so 11 minus 4 is going to be 7, and then the 10 minus 2 is going to equal 8, so we have 87. Oh, that's perfect. So 87 equals 87. That's true, so we must have done a good job here. Let's check out number 5 now. So for number 5, we have this equation of w minus $32.85 is equal to $24.93. So maybe you had some amount of money and you spent $32.85 and you were left with $24.93. So what did you have before you spent the money? So to solve this problem, we'll go ahead and use the addition property of equality and add $32.85 to both sides of this equation. So we're going to add $32.85 to both sides. If we go ahead and do that, on the left side, we're just going to get W plus 0. And on the right side, if we add these two decimals up, let's see what we're going to get. Adding together this $24.93 to this $32.85, let's go ahead and see. We're going to go ahead and add 5 plus 3, that's going to be 8. 9 plus 8 is going to be 17, carry the 1. The decimal is going to slide right down. 1 plus 4 is 5, plus 2 is 7, and then 2 plus 3 is going to be 5. So I think we're going to get here $57, that's right, $57.78. Now using the identity property of addition, we can go ahead and drop that 0 and just write W is equal to $57.78. There's our answer. Now to check this, let's take our answer of $57.78 and substitute that in for W. And so if we take that for W and then subtract the $32.85, let's see if that's actually equal to this $24.93. Okay, so let's see if that's true. If I take this $57.78, I'm going to leave off the dollar signs for now, don't need to write those, minus a $32.85. Let's see how that works out for us. So 8 minus 5 is going to be 3. I can't take away 8 from 7, so I'm going to borrow. I'm going to make this a 6. Thank you. And then that's going to be a 17. 17 minus the 8 is going to be 9. Bring the decimal straight down. 6 minus 2 is going to be 4. And then 5 minus 3 is going to equal 2. So we're going to get $24.93. So if the left side is $24.93 when you subtract, and the right side was $24.93, then this must be true. So that is accurate. Now let's go ahead and move on to some multiplication and division with number 6 here. For number 6, we have 4x, or 4 times x, is equal to 60. To solve this type of equation, we're going to go ahead and use the division property of equality and divide both sides by 4. On the left side, 4 divided by 4 is just going to equal 1, so we're going to have 1x, or 1 times x, is equal to, and on the right side, 60 divided by 4 is equal to 15. Now, instead of writing 1x, because the identity property of multiplication, we can go ahead and just drop the 1, because 1 times anything is just itself, so we can write that x is equal to 15. To go ahead and check this, we can substitute in 15 for x and say 4 times 15, is that actually equal to 60, right? That's the question you should be asking yourself. And if you go ahead and check this, 15 times 4 on this side, 5 times 4 is going to be 20, carry the 2. 4 times 1 is 4, plus the 2 is equal to 6, so 4 times 15 is indeed 60, and since 60 is equal to 60, we know that our answer is correct. X does equal 15. Let's try another. For number 7, we have the equation 84 is equal to 6c, or 6 times c. Now to isolate the variable c, what we're going to do is divide both sides by 6 using the division property of equality. So on the left side, let's say we have 84 divided by 6, and so 6 times 1 is 6, and then we're going to have a remainder here of 2. Bring down this 4. 6 goes into 24 how many times? I think it's 4, right? 4 times 6 is 24, and now we have a remainder of 0. Okay, so we know 84 divided by 6 is 14, so on the left side of the equation we can write 14. And on the right side, 6 divided by 6 is 1, so our coefficient is 1, so we have 1c. So if 1c is equal to 14, we can just say that c is equal to 14. We don't have to write that 1 by the multiplication identity property of multiplication. Now let's go ahead and check this real quick. So we have 84, is that actually equal to 6 times the 14 that we got? So if we go ahead and multiply here, 14 times 6 on the side, let's see how that works out. So 6 times 4 is 24, carry the 2, then 6 times 1 is 6, plus the 2 is 8, so that's 84. Oh, so that's really good for us, right? 84 does equal 84, so we know we are correct here. Cool. Let's check out number 8 now. For number 8, we have the equation k over 13, or k divided by 13, is equal to 7. To solve this equation, I'm just going to go ahead and rewrite it so we have a little bit more space to work with. So something divided by 13 is equal to 7. To solve this equation, we're going to use the multiplication property of equality and multiply both sides by 13. On the left side, we're going to multiply by 13, or 13 over 1, and on the right side, we're also going to multiply by 13. So as long as we're doing it to both sides, that's perfectly fine. On the left side of the equation, these 13s are going to cross-cancel and go bye-bye, so we're going to be left with 1k. And on the right side, we have to figure out what 7 times 13 is. So for 7 times 13, let's go ahead and multiply 13 by 7. 7 times 3 is going to be 21 and carry the 2. 7 times 1 is 7, plus the 2 is going to be 9, so we have 91. So I think 1k is equal to 91, so we can conclude that k is equal to 91. At least we think so, right? So we can always check this, which we're going to do, to see if this actually works. So to check this, let's go ahead and say, okay, we think k is 91, so what's 91 over that 13, or 91 divided by 13? Is it actually equal to 7? Well, we can go ahead and check this, but 91 divided by 13, even if we go ahead and write this long division out, you're going to notice that 13 doesn't fit into 9, so you're going to have to do your multiplication tables, and 13 times 7, let's just give it a go, that's going to be 21, carry the 2, 7 times 1 is 7, plus the 2 is 9, so indeed, this is going to be a 7, that gets us 91, with a remainder of 0, so we can say 91 divided by 13 is 7, so 7 does equal 7. So it checks out. Here's problem 9. For problem 9, we have the equation 2/3 h, or 2/3 of h, or 2/3 times h, however you want to think about it, is equal to 48. So just for more space here, I'm going to rewrite the equation 2/3 h, or 2/3 times that h, is equal to 48. Okay, so if this is 2/3 times h, what are we going to do? We're going to go ahead and divide both sides by 2/3 here. On the left side, we'll divide by 2/3. And on the right side, we'll also divide by 2/3. So on the left side, what happens when you have 2/3 divided by 2/3? Well, you're just going to be left with 1. So we have 1h. And on the right side, we have to figure out what this 48 divided by 2/3 is. So 48 divided by 2/3. Well, let's think about that. 48 is really just 48 over 1. So we're taking 48 over 1 and dividing that by 2/3. And keep in mind that when we are dividing fractions, we can actually rewrite it by multiplying by the reciprocal. So this is 48 over 1 times 3 over 2. That's the keep change flip there. And we could multiply the tops and the bottoms and then simplify, or we can go ahead and see that we can cross cancel here, right? So if we go ahead and cross cancel this 2 and this 48, half of 48 is 24. And the 2 is going to become a 1 if we take half of that. So if we go ahead and multiply 24 times 3 on top is going to be 72. And it's going to be 72 over 1, which is just equal to 72. So we know that 1h is equal to 72 now. So we know h, we can conclude, is equal to 72. That should be our answer. Now, should we go ahead and check this? Absolutely, right? So we have 2/3 times h. What do we think h is? We think h is 72. And if we are correct, then this will equal 48. So let's go ahead and check this out. So if we go ahead and say, okay, 2/3 times the 72, that's going to be 72 over 1. Can we multiply these? Yeah, we can. And then we can cross cancel 3 and 72. 3 goes into 72 24 times. And so what's 2 times 24 on top? 2 times 24 is 48. So we're going to get 48 over 1, which is just equal to 48. Okay, so this actually works out, right? We have 48 is equal to 48. So we found out 2/3 of 72 does equal 48. So h is 72. Here is one last problem. We have 3 and 2/3 is equal to 22/9 m, or 22/9 of m. Now let's go ahead and just rewrite this so we have a little bit more space. So we have 3 and 2/3 is equal to 22 over 9 multiplied by m. Now, the first thing I would do is go ahead and rewrite so we just have improper fractions. So if we go ahead and multiply and say, okay, 3 times 3, that's going to be 9. 9 plus 2 is going to be 11. We're going to have 11 over 3 is equal to 22/9 m. Okay, so on the right side, we have 22/9 times m. So what do we have to do to both sides of the equation? We're going to have to divide both sides by 22/9. So we're going to go ahead and divide both the left side and the right side by 22/9. Now on the left side, let's see what's going to happen. We have 11/3 divided by the 22/9. How do we rewrite that? Well, that's going to be 11/3 times, because we got to change the division to multiplication, the reciprocal, which is 9 over 22. Now we can do some cross canceling here. 11 and 22 becomes just 1/2. And then the 3 and the 9 just becomes 3 over 1. Multiplying these two together now, we're going to get 3/2. which is a much nicer fraction. So we just found out that 11/3 divided by 22/9 is going to be equal to 3/2. So I'm running out of space a little bit. I'm going to say 3/2 is on the left side of the equation. And on the right side, we have the 22/9 m over 22/9. What's 22/9 divided by 22/9? Well, that's just 1. So we have 1 m. And then by the identity property of multiplication, we could drop that 1 and just say that m is equal to 3/2. Okay, so there's our answer. Now to check this last problem, let's go ahead and take this 3 2/3 from the original problem and say, is that equal to this 22/9 times the answer we got, which was 3/2. We're going to go ahead and substitute that in. Let's see if this works or not. Well, let's go ahead and see what this 22/9 times the 3/2 is actually equal to. Let's see if we can do any cross-canceling. 3 and 9 becomes 1/3. And then what about the 2 and 22? They're both even, so you can divide them by 2. So we'll get 11 over 1. So let's see, on top, 11 times 1 is going to be 11. And on bottom, 1 times 3 is 3. And let's see, 11/3. How many times does 3 go into 11? I think it goes in 3 times with 2 left over. So it's 3 2/3. Thank goodness, because the left side was 3 2/3. And we got 3 2/3 when we checked our answer. So we can be pretty comfortable here that m does equal 3/2. And there you have it. We have 10 different examples here of one-step equations, so hopefully this was a good practice video for you. I hope you found it helpful, and as always, keep up the great work, and I'll see you in the next one.